Okay, so chapter 5a, number 12, is a way to prove these two angle sum formulas about cosine alpha plus beta and sine alpha plus beta. Um, it's actually not a full proof because it requires you to limit yourself to acute angles. So this one really only proves it for acute alpha and beta. But it turns out that the result still applies to any size angles. Um, and at some point, I'll do the other proof too. But right now, I feel like this one's a good one because it only uses right triangle trig, which is sort of neat. Um, the other one also uses just basic geometry, but it's a little bit uglier looking, in my opinion. So, um, okay, so we've got four right triangles that have all been fitted together, and they form a rectangle. And notice this angle here is alpha, this one's beta. Um, and then it says there are a couple, and then there's this length that's marked 1. And there are two unmarked angles. One of them is alpha and one of them is alpha plus beta. So one of the goals is to figure out where those are. So let's just try to fill in some of these angles. This angle right here has to be 90 because it's part of a right triangle. And I know that alpha plus 90 plus this missing angle has to be 180. So if I subtract the 90 and subtract the alpha, then this angle ends up having to be right here, 90 minus alpha. And if you think about adding it to the other two angles, you end up with 180 then. So this angle is 90 minus alpha. This angle is 90. If I add it to this angle right here, I should get 180. So 90 minus alpha plus 90 plus that missing angle has to equal 180. And the only way that's going to happen is if that missing angle is alpha. So this angle right here is alpha. So let me mark that, alpha. So 90 right here. This angle is going to be 90 minus alpha. This angle right here, I've got a beta and a 90. So this angle ends up being 90 minus beta, if you work that out. And then I know if I add these three angles all down here together, that should be 180. So I got 90 minus beta plus 90 minus alpha plus something has to be 180. And the only way that happens is if the something here is beta plus alpha or alpha plus beta. So that's this angle right here, alpha plus beta. Okay. And it turns out that's all we need to do the rest of this problem. So let me get rid of this stuff. I don't even know why I drew it so big. Here, let's use this one down here. So the angles that we found, 90 here, alpha here, 90 here, alpha plus beta here. That one's also got to be 90. So then really what we're supposed to do is just go around this thing and label stuff in terms of sine and cosine and alpha and beta. So let's look at, I don't know, let's look at this right triangle that's in the middle first. So this guy right here. Okay. So if I call this, I don't know, let's call this x and y. So if I solve for y, I know that sine beta is opposite over hypotenuse, so that's going to be y over 1. So in this case, sine beta is y. So this side right here is really, I'll put all the side lengths in blue here. This is really sine beta, this side length, right? So let's just write it right on there. Sine beta. Okay, and if I solve for x, I could do the same thing, but with cosine. So it'd be cosine beta equals adjacent over hypotenuse. So cosine beta is 1, or is x. So this side right here is really cos beta. And then this side we already know is 1 right there. If I wanted to figure out these two sides, here and here, let's call this like W and Z. So let's use this angle. So if I did sine of alpha plus beta, then I'm going to get W over 1, opposite over hypotenuse. So then sine alpha plus beta is really W. So this side right here is sine alpha plus beta. And then in the same way, if I did cosine alpha plus beta, I'll get z over 1. So then z down here is really cosine alpha plus beta. Okay, let's do this top side and this side over here. So let's see what letter. How about R and S? Okay, so if I did, let's do sine alpha up there. Well, then that's opposite, which is S, over the hypotenuse, which is cosine beta. So then I know S equals, when I multiply this over, I get sine alpha cos beta. So let's put that right here. So S is really sine alpha times cosine beta. And if I wanted to solve for R and use cosine alpha, then I'm going to get R over cosine beta. So R is going to be cos alpha cos beta. So that's this side right here, cos alpha cos beta. And then we got two sides left, this one here and this one here. So I don't know, how about, what am I? Let's go T and U. Okay, so we've got alpha right here. So if I did sine alpha, I am going to get opposite, which is T, over hypotenuse, which is sine beta. So T over sine beta. And then if I solve for T, I'll get sine alpha sine beta. So here it is. T is sine alpha sine beta. And then U, if I did cosine of alpha equals U over sine beta, then I'm going to get sine beta cos alpha equals U. So this side is sine beta cos alpha. And then I can set up some equations here based on this stuff. So looking at this, the sum of these two pieces down here is really the same thing as the top. So if I wrote over here, let's shrink all this down. So we'll put that way over here. So if I were to say cosine, if I took the bottom two, so alpha plus beta, plus sine alpha sine beta, I know that that's the same length as the top, which is cosine alpha plus alpha cosine beta. And so if I just solve for this, I get cos alpha cos beta minus sine alpha sine beta. So there's one of our two formulas that we have right here. Right? The other one is, well, let's look at this side. Right? So that side is sine alpha plus beta. That should really be this plus this. So if I write that out, sine alpha plus beta equals sine alpha cos beta plus, and then sine beta cos alpha, or you could have said cos alpha sine beta, and that's the way that it's written up here. So there are two ways to derive it, and I hope that helps. Okay. It turns out in the next problem, one of the things you do is you take these two and you switch out the betas for negative betas instead. So that becomes negative beta, that becomes negative beta, all the betas become negative betas. So then what you're really going to do is look at, you can use this idea. So let me first replace them all with negative betas. Minus sine alpha sine negative beta. And then you can think about, well, is cosine an odd or an even function? Is sine an odd or an even function? To figure out how to turn this into a cos beta and a sine beta. And then you figure out, do the signs change, or do they, like, does that become a plus or minus? Do you get a plus or minus out in front here? And then you end up with the angle difference formulas instead of the angle sum formulas. All right, hope that helps.